All right, this is chapter 8.2, analyzing arithmetic sequences and series. The essential question for this chapter is, how can you recognize an arithmetic sequence from its graph? What you will learn in this chapter is how to identify arithmetic sequences, write rules for these arithmetic sequences, and find sums of finite arithmetic sequences. So here we go. Okay, so identifying arithmetic sequences. In an arithmetic sequence, the difference of consecutive terms is constant. This constant difference is called the common difference and is denoted by the variable d. Okay, so that's what we're going to do here. So example 1 says identifying arithmetic sequences, tell whether each sequence is arithmetic. So I want to take the difference of each. So it's this term minus this term. So this is a sub 2. This is a, so let's do that first. This is a sub 1. This is a sub 2. This is a sub 3. And this is a sub 4. And finally, we have a sub 5. So we have 5 terms in this sequence, and it continues, but they gave us the first 5. So, excuse me, we're going to take the difference of each. So that'd be a sub 2 minus a sub 1. We're going to do a sub 3 minus a sub 2. We're going to do a sub 4 minus a sub 3, and finally a sub 5 minus a sub 4. And in doing that, a sub 2 is negative 2 minus a negative 9, which is plus 9 or 7. Negative 2 plus 9 is 7. A sub 3 is 5 minus a negative 2, which is plus 2. Well, that's going to give us 9. No, it's not. 5 plus 2 is not 9. It's 7. Hello. Okay, so anyway, a sub 4 is 12 minus a sub 3, which is 5. And that's giving us 7 again. And finally, a sub 5 is 19 minus 12, which is our a sub 4. 19 minus 12 is 7. When all of these are the same, okay, that is our common difference d. So I just confirmed that d equals 7. Okay, each difference is 7, so this sequence is arithmetic. Okay, and it's that simple. So here we go. Here's a sub 1. Here's a sub 2. Here's a sub 3. This is a sub 4. And the 3 is an a sub 5. So I'm going to say a sub 2 minus a sub 1, a sub 3 minus a 2, a sub 4 minus a sub 3, and finally a sub 5 minus a sub 4. So I want to find out what all these equal. So a sub 2 is 15 minus 23, which equals, well, 5 8 is negative 8. All right, so a sub 3 is 9 minus 15 equals negative 6. Uh-oh, we're done. A sub 4 is 5 minus 9, which equals negative 4. And a sub 5 is 3 minus a sub 4, 5. 3 minus 5 is negative 2. So as you can see, these are not the same. So therefore, there is no d, and therefore this is not, I forgot to switch back to my pen. All right, this is not arithmetic, because I do not have a common difference. Okay, so that's how you determine whether or not a list of numbers is arithmetic or not. So now you should be able to do problem numbers 4 and 6 in your exercises. Okay, so here we come to our first core concept of the chapter. Section, rule for an arithmetic sequence. Algebra. The nth term of an arithmetic sequence with the first term of a sub 1 and a common difference d is given by a sub n equals a sub 1 plus n minus 1 times d. What? Okay, so to find an nth term, you take the first term and add it to 1 less than the number term times the common difference. So in an example, the nth term of an arithmetic sequence with the first term of 3 and a common difference of 2 is given by a sub n equals 3, your first term, plus n minus 1 times 2. Or a sub n equals, if you distribute, 2n minus 2, but then you add that 3 and you get 2n plus 1. Okay, so it's just almost like a linear equation. It is actually in this situation, and therefore you get a arithmetic sequence with a common difference, which is your rate of change or your slope if you graphed it. So let's take a look. Okay, example 2 says write a rule for the nth term. Write a rule for the nth term of each sequence, then find a sub 15. So here's a sub 15. All right, so what are we going to do here? Well, this is my first term. So a sub 1 equals 3. And then I can find d, because d is the difference between 2. So d is 8 minus 3, or d equals 5. So I have a sub 1 is 3 and d equals 5. So I say a sub n equals a sub 1 plus n minus 1 times d. Okay. And then I simplify this by distributing the 5, and I get a sub n equals 3 plus 5n minus 5, right? Distributing n times 5, 5 times 1 right here. And then I'm simplifying this even further, and I'm going to put the 5n first, and 3 minus 5 is negative 2. So a sub n equals 5n minus 2. And now I want to find a sub 15. So I say a sub 15 equals 5. And since my n is 15, I'm going to put that right here. And then minus 2. So a sub 15 equals 5 times 15, which is 75, minus 2. So a sub 15, the 15th term in this sequence, would be 73. Okay, so when you're asked to find a really high number in the sequence, it's a lot easier to figure out what the formula is and then just substitute in that number rather than saying, well, add 5, add 5, add 5. Where am I? I'm on the 4th term. The 5th term would be 23, then 28, then 33, then 38, then 40. And it just takes way too long. So this is a better approach, and it gets to a result quicker. Okay, so here's the next one. So I'm just going to list what I have. A equals, or a sub 1 equals 55. And my d is going to be 47, my second term, minus my first term. So therefore my d equals negative 8. Okay, so I have my a sub 1, and I found d. So I'm going to say a sub n equals a sub 1, which is 55, plus the quantity n minus 1 times my d, which is negative 8. So a sub n is going to equal 55 plus, just kidding, I don't like writing plus or minus. A negative times a positive is negative, so plus a negative 8n is minus 8n. And then a negative 8 times a negative 1 is plus 8. Okay, so a sub n, if I rearrange this, is going to be negative 8n. And then 55 plus 8 is 63. So it's negative 8n plus 63. Okay, that's the rule. And now I substitute in my 15. So a sub 15 substituted into this rule equals negative 8 times 15 plus 63. So a sub 15 is going to equal 8 times 5 is 40, carry the 4. 8 times 1 is 8, plus 4 is 12. That's negative 120 plus 63. So a sub 15 equals 60 and 60 is 120, so this would be negative 57. So a sub 15 equals negative 57, meaning the 15th term in this sequence, if we continue, this is decreasing by 8 every time. 15 numbers out would be the negative 57. Okay, so that is how you write a rule and find an nth term of a sequence. Now you should be able to do problem numbers 14 and 18 in the exercises. Okay, example 3 is writing a rule given a term and a common difference. So here we don't have a list of numbers. They just gave us one of the terms and D. Okay, so one of the terms of the arithmetic sequence is a sub 19. A sub 19 equals 45, and the common difference D is negative 3. So we're given a sub 19 and we're given D. So we just write our formula, and our formula is a sub n equals a sub 1 plus n minus 1 times D. So you write a formula and then you substitute the givens. So it's going to be a sub 19 equals a sub 1 plus, and since it's the 19th term, our n is 19, so this n is also 19. So it's going to be plus parentheses 19 minus 1, and then our common difference is negative 3. So I plugged in 19 here and here, and the negative 3 here, and then we just simplify. So a sub 19 equals a sub 1 plus 18 times a negative 3. So a sub 19 equals a sub 1 minus 8 times 3 is 24, carry the 2, 3 times 1 is 3, plus 2 is 5, negative 54. So I have two unknowns here, but I don't, because I know a sub 19 is negative 45. So I'm going to substitute in negative 45 for a sub 19, like so, and I get a sub 1. Oops, not equals, minus. So it's a sub 1 minus 54. So I add 54 to both sides and I get my first term. Okay, these cancel and I get a sub 1 equals 54 minus 45 is 9. Okay, so my first term is 1 and my first term, n is 1, a sub 1 is 9. Okay, and so now that's all I need. So now I know my rule. My rule is now a sub n equals a sub 1, which is 9, plus n minus 1 times negative 3. And if I distribute that, I get a sub n equals 9 minus 3n plus 3. And then when I rearrange this, a sub n equals negative 3n, and 3 plus 9 is 12. So my formula is negative 3n plus 12. So our first term, a sub 1, n is 1. Okay. So if n is 1, a sub n is 9. And my common difference is negative 3. So my second term is going to be 3 less than 9, or 6. My third term is going to be 3 less than 6, which is 3. My fourth term is going to be 3 less than 3, which is 0. And my fifth term is going to be 3 less than 0, or negative 3. And my sixth term is going to be 3 less than negative 3, which is negative 6. Okay. So you can take any one of these numbers and plug it into this formula. 6 times negative 3 is negative 18, plus 12 is negative 6. Okay, so now we're going to graph these. So when x is 1, y is 9, or n is 9, if you will. When this is my n. So instead of my x-axis, I have my n-axis, and this is my a of n, a sub n, or my y. Okay, so when n was 1, a sub n was 9. When a is 2, or n is 2, a sub n is 6. When it's 3, it's 3. When it's 4, we're at 0. 5, -3, and 6, -6. Okay, so as you can see, this is a straight line, and I'll do it in red. So if I started here, as you can see, they're all right on a straight line with a slope of -3. And if I went to the left, then my y-intercept would be 12. Okay, when n is 0, of course, we're not going to go to our 0 term. That makes no sense. Our first term, we're starting here. This is a starting point. But it is a linear equation that would line up with 12 being the y-intercept if we went to a 0 term, which doesn't make any sense. Okay, so that is writing an arithmetic sequence and graphing it given a term and a common difference. So now you should be able to do problem numbers 24 and 26 in your exercises. Okay, here's another approach, writing a rule given 2 terms. So if we go back one, this was given 1 term and the common difference. Here they're giving us 2 terms. So we don't know the first term and we don't know D, but we do know the 7th term and the 26th term in this problem. So what we're going to do is focus on these 2 terms and find a sub 1 and D using them. So the first thing you do is write your formula. So the formula is a sub n equals a sub 1 time plus n minus 1 times D. Okay, so I'm going to write this twice with these 2 values substituted in. Okay, so the first thing I'm going to do is substitute in 26, do the larger term first. So let me change the color of one of these highlights. So let me delete this and let me change the highlight of this to purple. So I'll use green and purple. Okay, so we're going to start with a sub 26. So I'm going to put a sub 26 equals a sub 1 plus, and then 26 minus 1 times D. So all I did was plugged in my n, my 26. That's all I know. I don't know my first term. I don't know my common difference, but I do know n is 26. So a sub n is a sub 26, and this n is 26. Okay, so that's the first one. And then what I'm going to do is I'm going to then do the same thing for the second one, but it's going to be a sub 7 equals a sub 1 plus 7 minus 1 times D. Okay. And we were given values for this. So a sub 26 is 93. So what I'm going to do now is I'm going to switch over and plug in this 93. So a sub 26 is 93. So this a sub 26 here becomes 93. And that's going to be a sub 1 plus, and now we're going to simplify this. 26 minus 1 is 25 times D. So I get 93 equals a sub 1 plus 25D. I'm going to do the same here. A sub 7 is 17. So I put a 17 where a sub 7 was. I don't know a sub 1 yet. Plus 7 minus 1 is 6D. Okay, and then what I'm going to do is I'm going to subtract these 2 terms. So I'm going to now subtract. So I have to borrow here. So 13 minus 7 is 6. 8 minus 1 is 7. Equals a sub 1 minus a sub 1 cancels. 25 minus 6 is 19D. Divide both sides by 19. And D equals 4. 19 and 19 is 38. 38 and 38 is 76. So I found D. D is 4. So now what I can do is take the 4 and plug it in here. Okay, or actually right over here. So now I'm going to take this 93 equals a sub 1 plus 25, and I'm going to plug in my 4 right here and find my a sub 1. Okay, so I now know D, put D in the first line. 93 equals a sub 1 plus 100. Subtract 100 from both sides and we find our first term. 93 minus 100 is -7. And there's my first term. So for this sequence, it will be a sub n equals a sub 1 plus n minus 1 times d. And when I simplify this, I get a sub n equals -7 plus 4n minus 4. Rearrange, a sub n equals 4n, and -7 minus 4 is -11. So the sequence rule is a sub n equals 4n minus 11. And there you have it. You can always check to see if 7 works in here. 7 times 4 is 28. 28 minus 11 is 17. It checks. I can also plug in 26 here. A sub n equals 26 times 4. 26 times 4 is, let's see, 104. Is that right? 26 times 4, 104 minus 11, 93. That is correct. Okay, so that's how you do it. Use the formula, substitute your givens, create two equations, and subtract them to get rid of your a sub 1 and solve for d. Substitute in your d to find a sub 1. Now you should be able to do problem numbers 31 and 34 in your exercises. Okay, finding sums of finite arithmetic series. Okay, a series. The expression formed by adding the terms of an arithmetic sequence is called an arithmetic series. Okay, so adding the terms of an arithmetic sequence is an arithmetic series. So the sum of the sequence equals the series. The sum of the first n terms of an arithmetic series is denoted by S sub n. S for series, A for arithmetic. A sub n is now S sub n. Find the rule for S sub n. You can write S sub n in two different ways and add the results. So S sub n equals the first term, A sub 1, plus A sub 1 plus that common difference, plus A sub 1 plus 2 times the common difference, and so on, and so on, and so on. 3D, 4D, 5D, 6D. Okay, so then you take S sub n equals A sub n, a first term. S sub n equals some term, A sub n, plus A sub n minus d plus A sub n minus 2d, and so on, and so on, and so on. Well, when we add these two rows, we get S sub n plus S sub n equals 2S sub n. A sub 1 plus A sub n equals A sub 1 plus A sub n. And then we'd get A sub 1 plus A sub n here, and the d's cancel. And then we get plus A sub 1 plus A sub n here because the 2d minus 2d cancels. So the d's are going to cancel every time, leaving us A sub 1 plus A sub n repeated the number of times. Okay, so A sub 1 plus A sub n is added n times. You can conclude that 2S sub n equals n times A sub 1 plus A sub n, which leads to the following result. So get rid of this 2 by dividing both sides by 2, and we get S sub n equals, so the sum of the first n terms of an arithmetic series will become S sub n equals n times A sub 1 plus A sub n divided by 2. In words, S sub n is the mean of the first and nth terms. Okay, mean meaning average. So you take the nth term plus the first term and divide by 2. Since there's only 2 terms, that's the average or the mean of the first and nth terms multiplied by the number of terms. Okay, so that's might be a little foggy there, but when we do an example, it will hopefully clear up. Okay, finding the sum of an arithmetic series. So it says to find the sum of, and there's our sigma notation for a summation, from I equals 1 to 20. So we want from the first term to the 20th term. So right there, I'm going to say A sub 1 equals 1, and A sub 20 equals what? Actually, A sub 1 doesn't equal 1. We want A sub 1 and we want A sub 20. So A sub 1 equals 3I plus 7, where I is going to be 1. So why did I write on I? It's 3 times 1 plus 7. And 3 times 1 is 3, plus 7 is 10. Okay, so A sub 1 equals 10. and I want a sub 20. So plugging 20 into here, we get 3 times 20 plus 7. Well, 3 times 20 is 60, plus 7 is 67. So my first term's 10, my 20th term is 67. And then I use that formula we just learned, S sub n, the sum of the series, arithmetic series, is going to equal, so I'm going to substitute in my givens now. S sub n equals, n is the number of terms, which is this number up here, from 1 to 20. So actually, it's not that number up there. It's this number counted from this number. So if I go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. That's 20 terms. So it's this minus this plus 1. Because you have to count the first term, right? So anyway, there are 20 terms from 1 to 20. So n is 20. Parentheses, a sub 1, which is 10, plus a sub n, which is a sub 20, which is 67, all over 2. So s sub n is going to equal 20 times 77 divided by 2. So s sub n is going to equal, well, watch what I'm going to do here. 20, think of that as over 1. And this is a denominator, so 20 divided by 2 is 10. And 77 times 10 is 770. So the sum of this arithmetic series is 770. Okay? It's actually pretty easy, isn't it? Calculate the first term, calculate the last term, determine how many terms there are. Because if I started at 4 and went to 20, that'd be 20 minus 4, which is 16, plus 1 is 17. So 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20 is 17. All right. So once you calculate that, that is your n. Substitute in your first term, your nth term, and your n, and calculate. So now you should be able to do problem numbers 48 and 52 in your exercises. Okay, so now we're going to put that into practice. So example 6 says solving a real life problem. You are making a house of cards similar to this one shown right here. Write a rule for the number of cards in the nth row when the top row is 1. So the top row is the first row, or a sub 1. And as you can see, it takes 2 side cards and the bottom. It's a triangle. So it takes 3 sides, 3 cards to make that one row. So the first thing we're going to write is a sub n equals a sub 1 plus n minus 1 d times d. Okay? So I know my first term, a sub 1, is 3. So a sub n equals 3 plus n minus 1. Okay, my first row has 3 in it, and each row is going to be a common difference of 3. So I'm also going to put a 3 in there. Substitute 3 for a sub 1 and 3 for d, because starting with the top row, the number of cards in the row are 3, 6, 9, 12. These numbers form an arithmetic sequence with the first term of 3 and a common difference of 3. Okay, there are 3 cards here, and then 1, 2, 3, 4, 5, 6 in the second row, and then 1, 2, 3, 4, 5, 6. So in other words, there were 3 in this row, and then 1, 2, 3, 4, 5, 6 in the second row. 1, 2, 3, 4, 5, 6, 7, 8, 9 in the third row. And that is a common difference of 3. Okay, I had to add 3 to go this way, so I shouldn't put plus 3. I should actually go the other direction, because that's what the word difference means. So if I'm going this way, I'm subtracting 3. If I'm going this way, the common difference, I'm subtracting 3. So the difference is 3. Okay, so a sub n equals our first row, 3, plus n minus 1 times 3. Simplify that, and I get a sub n equals 3 plus 3n minus 3. And a sub n is just simply 3n because the 3's cancel. Okay, so that's A. Write a rule for the number of cards in the nth row when the top row is 1. So here's our rule. A sub n equals 3n. Okay, so if I plugged in a 3 for my third row, 3 times 3 is 9. And that's exactly what that is right there. Okay, so now moving on, it says B, how many cards do you need to make a house of cards with 12 rows? So they want to know how many total cards. That's an arithmetic series. So I want S sub n, and S sub n equals n times a sub 1 plus a sub n divided by 2. Okay, the sooner you understand what we're doing here, the easier it is. It's not a matter of memorizing a formula. It's a matter of thinking about the formula and writing it down. It's the first term plus an nth term divided by 2. Remember, the mean of the first and nth terms times the number of terms. Now I can substitute my givens. So how many cards do you need to make a house of cards with 12 rows? So my n is the number of rows, 12. So that's going to be S sub 12 equals 12 times my first term, A sub 1. A sub 1 was 3 plus, and then A sub n is going to be 12, let's see, it's going to be 12 times 3, or 36, divided by 2. Okay, so how did I get this? I wanted the 12th row. Well, 12, A sub 12 is 3 times 12, or 36. So the sum of all of these is going to be S sub 12 equals 12 times 36 plus 3 is 39 divided by 2. And then always cancel if you can. 2 and the 12 become 6. So S sub 12 is going to equal 39 times 6. 9 times 6 is 54. Carry the 5. 6 times 3 is 18. Plus 5 is 23. So to make a house of cards with 12 rows, I'm going to need 234 cards. Okay? So that's how you find an arithmetic series. Now you should be able to do problem numbers 55 in your exercises. Okay, so that brings us to the end of chapter 8.2. Here are the exercises that I assigned throughout the video. Thanks for watching and have a great day.